I've been investigating and tracking deadly Pokémon for 3 years now. Electric types, water, poison, grass, rock, fire. You've seen my reports. But nothing prepared me for this one. I sealed my fate months ago. Let's start from the beginning.
Vsauce! I'm Jake and I am here in the UK because I have been playing a lot of Pokémon Go, and as you probably know, there are some Pokémon that are region specific, and here in the UK and in Europe, there is a very deadly Pokémon, and one that I must find because it might just be the most dangerous Pokémon we have yet to encounter. That's right, Pokémon number 122, Mr. Mime. Mr. Mime can shape an invisible wall in midair by minutely vibrating its fingertips to stop molecules in the air. But what if they were your molecules? That was me a few months ago, I think. I'm not really sure, it's hard to keep track of time here. But to understand why Mr. Mime is so incredibly dangerous, we first need to discuss how to slow down a molecule, that is, reduce its movement or energy. The lower their temperature, the slower they will be moving. So let's begin our journey by going to a temperature that nobody has been able to achieve, that we have yet to even find anywhere on Earth or in space. Infinite cold. Absolute zero. Absolute zero is 0 degrees Kelvin. To put that into perspective, the coldest natural place recorded on Earth was in Antarctica at 184 degrees Kelvin. In our solar system, it's a perpetually shadowed crater on the moon at 33.15 Kelvin. And in the universe, 5,000 light years away at the Boomerang Nebula, which has a temperature of 1 Kelvin, the lowest natural temperature ever recorded. In general, the universe has a temperature of 2.7 degrees Kelvin because of the residual cosmic microwave background radiation from the Big Bang that still remains. 2 degrees is pretty darn cold, but in labs, we've gone colder. In one particular study, scientists were able to cool a piece of rhodium metal to 0.0000000001 degrees Kelvin, the lowest man-made temperature ever recorded. We're still not at absolute zero though, but some interesting things happen as we approach these extreme temperatures. For instance, we start to experience superfluids. If we take the gas helium down to 4.2 Kelvin, it becomes liquid helium-1. If we go even further, past 2.17 K, liquid helium becomes a superfluid. That is to say that it now has 0 viscosity. In this example, we see a glass that has hundreds of 1 micrometer holes in the bottom. Normal liquid helium doesn't come through the holes because the liquid is viscous. However, once it transforms from helium-1 to helium-2, the superfluid, it loses all viscosity and starts to drip out. Some studies have shown that hydrogen can also become a superfluid. Hydrogen makes up 9.5% of our bodies, so if that happened, it would leak out through our pores, even though on average a pore is about 0.08 micrometers in size, smaller than the 1 micrometer holes in the video. But as physicist Alfred Leitner says,
the rate of pouring would not be noticeably slower if the porosity were made yet finer.
Liquid helium is generally used for superconducting magnets. The thousands of magnets that direct the proton beam around the 27-kilometer ring at the Large Hadron Collider are cooled using liquid helium. But we keep getting colder, and since we're dealing with something as small as molecules, they're governed by quantum mechanics. At this temperature, molecules don't collide anymore because their quantum mechanical waves stretch and overlap, forming a Bose-Einstein Condensate, a state of matter in which separate atoms or subatomic particles, cooled to near absolute zero, coalesce into a single quantum mechanical entity, a giant matter wave. The good news is that there are a few problems with reaching absolute zero. As MIT professor Dr. Seth Lloyd puts it, the time scales get longer the smaller amounts of energy involved. It would take the age of the universe to do it, and you need something the size of the universe to do it. Not to mention the third law of thermodynamics, that the entropy of a perfect crystal is 0 when the temperature of the crystal is equal to absolute 0. And you also have the Heisenberg uncertainty principle. The Heisenberg uncertainty principle states that you can't know both an atom's position and momentum, therefore you can't bring something to absolute 0 because you know both. In quantum mechanics, you can't have things be absolutely still. Even at absolute 0, there always has to be some motion, some energy contained in a system, in its quantum mechanical ground state. Or another way to phrase it, it's 0-point energy. its lowest possible energy. As far as we know, absolute zero is unattainable in physics as we know it. But the rules and laws that govern us don't matter to something like Mr. Mime. You see, the entire time I thought I was tracking it, when it was tracking me. And now that I know all this, I was finally able to realize why Mr. Mime is so deadly. With Mr. Mime, there is no gradual or even rapid drop in temperature to experience the effects of near absolute zero. If there were, though, you would get very cold. You'd get hypothermia. Your heart starts to slow down. Your body would try to keep your core warm, so your extremities would begin to fail. You would lose consciousness as you froze to death. The temperature continues to drop. The cells in your body would burst as they froze and expanded. It gets colder. The hydrogen in your body would become a superfluid and leak out of your pores. But with Mr. Mime, it's instantaneous. You become stuck, frozen in place. To the outside world, you would likely be a black, massless shape. No light would be absorbed, reflected, or scattered. Or you might not be able to be perceived at all. Every atom that makes you would be flattened out and no longer distinguishable from one another. You'd be a quantum system of matter. It's been speculated that if you could bring atoms down to absolute zero, their wave functions would extend across the universe, meaning those atoms, those pieces of you, are located nowhere, trapped in this nothingness. Once Mr. Mime releases its hold on you, any form of light would agitate your atoms, warming them up, freeing you from your quantum state, but dispersing you as well. In short, Mr. Mime would freeze you and then disassemble you on a quantum level. There would be nothing of you left. Carl Sagan famously said, "We are made of star stuff." And Mr. Mime would return you back to that. I can only hope he'll release his hold on us soon. And as always, thanks for watching. Hey, get ready for a tonal change because we're going to talk about something very exciting. Two things. In fact, the first is the Curiosity Box by Vsauce. This is something that we really care about and are really excited about. It's something that we've been working on for over 2 years. It's a quarterly subscription box made by Vsauce, Michael, Kevin, and myself, and it's filled with cool science toys, science experiments, books, t-shirts, other fun stuff that I won't spoil for you, but it's really incredible, and a portion of the proceeds goes to Alzheimer's research. Because of these boxes, we've been able to raise over $55,000 for Alzheimer's, which is truly incredible. So if you want to get in and get your own, there's a link in the description. If you want to see what's inside, there is a playlist right here with my unboxing and also a bunch of unboxings from other subscribers. It's really cool. A lot of the stuff is exclusive. We make and manufacture a lot of the experiments and a lot of the toys, so it's pretty darn neat. The second thing is, I get asked a lot, Jake, where's Dong? Where's Game Loot? Well, I have good news for you. It's that we're making those all the time now on youtube.com/dong. You should definitely subscribe. It's Michael, Kevin, and I hosting 2 videos every single week of loot, Game Loot, Dong. It's really cool. It's really exciting. So if you want more Vsauce in your life, there's the Curiosity Box. If you want more Vsauce on your computer, there's the Dong. The choice is yours. Okay. Farewell, my friend. Beep boop, beep, beep, beep. You didn't know I was a robot, but I am a good one.